Um, so just want to kind of go through some various announcements today. So thank you everyone for getting your midterms in. I will return them by Friday. I apologize. I'm trying to basically give as many kind of personalized comments as I can. Like, I think everyone did a really great job, and it was really neat to see everybody's insights. So I will probably be contacting some of you if it's going to be okay to share some of your visualizations, because I thought some of them were pretty neat. So again, I will have that to you by Friday. So homework 5 has also been returned. So please let us know if there are any issues or if you have any questions on the grading. Homework 6, I am pushing the deadline for homework 6 because of all of the issues with power and internet connectivity. I am pushing that deadline to tomorrow at 11:55 p.m. So hopefully that will help everyone. We will try to get the recording up as soon as possible for those who might not be able to attend right now. Okay, so let's see. And then we have week 7. Did I make Amanda sorry, Amanda, I'm going to have to I think I need to make Eric co-host. Yes. So Amanda, I have today for week 7 presentations, I have Farzana, Becky, and Amanda. And we will start off with our presentations. After that, we'll go into Maria's points. So was there anyone else that I missed for week 7? I have this nagging feeling that I missed somebody, but I wasn't sure. And if they are, just send me a private message in chat and I will make sure to fix that. So I'm going to stop sharing my screen. Just a second. So Amanda, are you ready to go? Oh, Sam, I'm sorry, Sam. I forgot you were also on the list. Okay, so what if Amanda is ready?
I am ready. Can everyone see my screen?
Yep.
Okay, great. So hi, everyone. My function of the week is the unite function, and this is part of the tidyr package. So what is it for? It's basically like concatenating information. So this little graphic here, I think, kind of shows well what it does. So in the original data set, we had the century column and this year column. And then you can see after using the unite function, it has combined 1999 into one column in this observation here. So then I've got the arguments listed out here. I won't go into those into detail, but they'll be up when Ted posts this. But the first thing I'll kind of go over is the different variations and how you can combine the columns in your argument statement. And this seems a little basic, but there is kind of some neat things to it. So that's why I wanted to go over it. So sort of just the default here is, you're uniting your data set, and you've got then here what your new data set is going to be, or the new column is going to be called that you're creating. So I'm creating the species island, and then I'm adding these two columns, species and island together. And so the table down here shows it better. So the species island is the new column. And you can see I've combined species and island. And I'm specifying here that I'm separating my two columns that I want to combine with a comma. And again, I'll tell you in a minute why I'm emphasizing that. So another way that you can combine your two columns is just by adding a colon. So here I've just done species island, and then I've created the new column down here. And now I'll get into why I'm harping on this so much. So the other cool thing you can do is you can basically combine as many columns as you want. So in the table, you can see here, I've shown you species, island, and bill length. And in my argument statement, I don't actually have to specify island. I can use the colon and R nose to include everything every column that's included there between species and bill length. So in the combined column, it has combined all three of those. So that's just kind of a cool thing with the colon that you can do. And then, so once you've created your new column, there's a lot of really fun ways you can actually combine the two pieces of information. So the default is R is just going to add an underscore. So you can see here, it's just added an underscore between the species and the island. You can add a separator argument. So here I'm adding a separator argument and I'm telling it to add a space. So now I have a space in between my species and my island. You can completely remove a space, which is what I've done in this next example. You can add a comma and a space. And what I think is really cool is basically you can add whatever you want. So in this example, I'm doing a comma, and so I've added text, I've added spaces, and now I've got kind of a whole new set of information in this new column. And then working with missing values. So you do have in your argument statement, the default is it will, now I'm forgetting if the default is that it will keep it or not. And I have it up there in my arguments where I explain what each one is, but you can use your NA argument here and tell it whether or not you want it to include missing values or not when you've concatenated your information. So here, by saying true, I don't want it to include the missing values. So you can see in the column, the new column that I've created here, it is not including the NA value that is here in the bill depth original column. I will just kind of throw a little shout out. There is a complement to this called separate. So it's basically the opposite of what I've just ran you through. And I wasn't positive if somebody else was presenting on this, so I didn't want to go into it in too much
Farzana
detail.
is going to be talking about separate rows, which is related.
Perfect. Then I won't steal her thunder. And then I do think this is really helpful, not necessarily in terms of analyses, but in terms of preparing reports and preparing information you want to share. Kind of my initial example and thought was sort of creating a table one. A lot of times for manuscripts, you're combining, percentages and counts and numbers. And so a lot of times you're wanting to add in parentheses or percent symbols. And for me personally, I usually end up doing a lot of that by hand. So I thought this was a really cool way to kind of add that information in ahead of time. And then you can be printing something out that is already ready to go and the formatting is taken care of for you. Any questions?
Yeah, I've actually got one. How did you get your HTML document to look like that?
So this is actually last week when we were going over the different kind of RMD output styles. This is one of the options, and I'd be happy to share my RMD code that I used. I'm forgetting which style I used, but yes, it was one of the options I used.
Okay, cool. Yeah, it looks really nice. Yeah, just like whatever I guess is in the YAML header or whatever would be cool.
Yep. Yeah, I'd be happy to share that. I'll look it up after this and I can post it in the comments.
Yep. Great. Thank you so much, Amanda.
Yeah, thank you.
Any other questions? Oh yeah. So Sarah's point. So it's cool to create a unique column identifier using many columns. So this is actually it's really helpful. So for example, if you wanted to have a unique identifier that for the penguins with species, island, and then you could add kind of a unique number. I have an example of that that I'm happy to show later. But great job, Amanda. So who wants to go next? I'm going to nominate someone if someone doesn't step forward. Sam, would you like to present? Oh, okay. Farzana just spoke up. So why doesn't Farzana go next? Since it's that's kind of tied to what Amanda just presented.
Hi, can you hear me?
Yep.
Okay, so my function is separate rows. It's from this tidyr package, and what it does is the exact opposite of what Amanda just showed us. So when we have a data set like this where values are separated, and I mean for one observation we have multiple values for one variable, then we can use separate rows. So the argument goes like this: separate rows, then data, and then the variable we want to separate, and then convert. I think what it does is converting the character variable to a numeric variable. So here we have 3 of these data points, and now we have 3 rows for these 3 data points. So we can also use it for multiple variables. So we can just write it next to the first variable, and it will also separate them. Yeah, so it's helpful when we have a data set like this. So I haven't worked with such data set yet. So, but it's good to know.
Yeah.
Yeah.
I would say this is it. And great job, Farzana. Any questions for her? So do you use separate with dates a lot? So what do you mean, Sarah?
So not infrequently, I have to do like Qualtrics surveys where I want to take the recorded date and separate that out into its smaller parts and days, months, and years. Is this a function you can use to do that?
So there are functions in Lubridate that are probably a little more helpful. I'm going to put them in, like, so for example, there's Lubridate year, and that's going to extract the year from your date format. And then I think there's Lubridate month and then Lubridate day as well. And so that's the wonderful thing about the Lubridate package. Again, we don't have time to go through everything, but it's just enough to give you give you enough knowledge so you can move forward. I will say, so great job, Farzana. So I would say the number one use that I've seen this for is when, like, for example, if you think about movies and there was a column called genre, there are movies that actually span multiple genres. So how do you code that if you want one row per movie? And so you could put for like example, yes, or wait, sorry, what was, sorry, something like Star Wars. Okay, I'm going to make people mad. So you could say it's both sci-fi and science fiction. And you would put sci-fi, science fiction. But sometimes it's a lot easier to basically have a single line for each of those. So you would have two rows, like Star Wars, and then the genre would be sci-fi, and then the second one would be fantasy. And yeah, so Bradley worked on this. So hopefully we'll get to kind of share some results.
Yeah, just for that function worked really well for on my midterm. Like I basically just did that.
Yeah, so thank you so much, Farzana. I thought that was great. Sam, would you like to go next? Oh, and Amanda has pasted into chat what she used. She used art for her markdown document. So.
All right. So I had the string wrap function for my function of the week. It's a part of the Stringr library. It's a pretty simple function that gives us a way to wrap strings into paragraphs. So I have a couple of example strings here. It's usually used with wrapped inside of the concatenate function to actually split the strings into separate rows. So first I have the Stringwrap function here, just without the concatenate function. And it basically, you set a width of characters that it shoots for, and it inserts these line breaks. And then if you end up wrapping that in the concatenate function, it actually takes those line breaks and separates the data onto separate lines. And then there's only two other arguments in the Stringwrap function. You can add an indent, which just indents the first line, or you can add an extent, which just indents every line apart from the first row. So yeah, pretty simple function. If you set the width to 1, it just puts every word of the string onto its own row. As far as whether or not it's helpful, I don't know that I could speak to whether or not it is, because I haven't used like a lot of data with long strings, but I would imagine it would be helpful to be able to format those if you do have data with long strings. And that's pretty much it for Stringwrap, if anyone has any questions.
Any questions for Sam? So Stringwrap is a function that doesn't seem that useful until you need it. I would say the number one thing is, like, if you had labels that were really long, you know, it would basically it would shove over your ggplot. So what you can do with something that has kind of spaces in it is that you can actually put in, you can, like Sam was saying, you can put in line breaks. And so you can break up a label, like a really long label, into multiple lines. And the other use for it is, I haven't had time to talk about it, but in things like Plotly, when you have tooltips, if you don't want something spanning across the entire screen, like the tooltip box, you can use Stringwrap to insert those line breaks so the box that's shown is a little smaller. So great, thank you so much, Sam. Any other questions for him? Okay, so Becky, I have you last. Are you ready to present?
Yes, I am.
Okay, great.
Get the right screen up. Okay. Can you all see my screen?
Mm-hmm.
Can't really. Okay. So I have Patchwork for the function of the week that I chose. It actually is really cool when it comes to graphing. It's off of, it uses mainly ggplot2, and Patchwork is, sorry, is where it's, dang it, hold on. I just had a brain fart. I apologize, y'all. So it's, yeah, it's from that package Patchwork, and it works mostly off ggplot. So I'm gonna scroll down. I actually took some code from my midterm and kind of cleaned it up a little bit to show you. So what it can do is it takes graphs and it puts them together. That's sort of a growth statement. But so I think it's helpful. From the help section, I found that when you're dealing with multiple plots that have really complex compositions, it can kind of put them together really nicely and align them so that everything's together on one graphic rather than having multiple. And so if you look, I have my two separate graphs here, and when I called them item 1 and item 2. So when I used Patchwork, all I had to do was take my item 1 plus my item 2. So I programmed, you know, I called my graphs item 1 is this graph, and then item 2 is my second graph. So rather than looking at them separately, I just put in this neat little addition sign, and Patchwork pushed them together pretty cleanly. So they're sitting together side by side, and their Y values are, I mean, they're the same, so they're aligned really nicely. This isn't the only thing Patchwork does. This is from the empty cars set that actually came from the website. Where is that? There's a website that's actually referenced on here, right here, that Patchwork data website. And so you can see another example of just adding two graphs together. Another thing that it does is you can use the division sign right here, and you can get them on top of each other, so they'll stack up pretty nicely. You can use other mathematical operators too to combine them. And again, using that same stuff, I have these graphs right here. You can see that they're all aligned, and then you get this cool little one below it. And so I thought this is really helpful because in biosets in particular, when you're trying to make your stuff look really clean and concise, you don't have a bunch of graphs everywhere. So for me, I thought it was a really neat function because I could just put everything into one graphical display instead of having several. And that's what I think is it as awesome as sliced bread. That's kind of a hard tie right there. I really like sliced bread. So yeah, but it is a really awesome function.
Great job, Becky. This is one of my favorites. Like I'm using this, for example, we have these really complicated figures we're generating for a paper, and some of them have 8 subfigures. So we're using Patchwork to basically kind of compose a large figure. So yeah, great job, Becky. So it is a package that's worth looking into. It will basically kind of save your bacon when you're trying to make combined figures. Okay. So great job with presentations, everyone. So I'm going to share my screen again, and we'll talk a little bit about muddiest points from last time. Just a second. And I do have to say, it is really fun for me to see how everybody kind of comes up with examples for these. And, I think hopefully these are really helpful for you. We tried to pick things that you will kind of need at some point in your career. And like I said, most of these were voted on by the larger R community as being useful. So hopefully the majority of them are useful. Okay, so let's talk about some muddiest points from last class. So I did get the feedback that lists are a little confusing. And they're still very new. So I will say, yes, they're weird. So how do people feel about lists after the homework? Do you feel good? Do you feel like you want some more? Sorry, I am just trying to get the chat window up and going again because. Okay, so I have one person feeling okay with lists. Yeah, so we'll be working with lists today, and I just wanted to clarify. There were some questions about like the different ways to access stuff in lists.
I actually do have a question about that, Ted, if you
Sure.
don't mind. So during the homework assignment, there was one part, I can't remember, like I couldn't figure out how to get it to look nice with the double bracket. So I ended up doing like 3 like $sign like concatenated together in a row. But yeah, I was just trying to think of like, I couldn't think of a way that we were kind of trying to do it like with the brackets.
Okay, so let's talk about it. So which problem are we talking about?
I'm looking it up right now. It was near the end. I think when we were making the functions, let's see. pulling it up right now. All right. Okay, so let's see. Okay. Oh, so it was my lines might be slightly different than yours, but around line 53, it was asking find the maximum age at diagnosis for, and then it did DFS double bracket smoke2.xlsx. So I couldn't really think of a great way to add age at diagnosis into that. So what I ended up doing is just DFS $smoke2.xlsx $age at diagnosis.
So that's one way to do it. So I'm going to show, I don't have any components. So this will probably help other people. So I'm going to go over it. So the key thing to remember is that what comes out when you use a double bracket accessor is actually a data frame. So you can use that data frame directly. And this is why double bracket is like so important. So you can just pipe this directly into summarize. So if I say max age is equal to max. Does that make sense? But the key thing is that when you're accessing with a double bracket accessor, you're getting the actual item out of it. And in our case, it's a data frame, right?
Yeah, so that makes sense. That's actually exactly the type of answer I was looking for.
Yeah. So everyone is free to use this answer. Since I gave it, I will cut and paste it into chat. So yeah, so that's, I wanted to go over a little bit about the single bracket accessor because there is a lot of confusion about it. What I will say is 99% of the time, you should be using double brackets because again, you want to return what's in the list slot. So if you see like, what we're putting into my list. So we're putting in 3 character vectors. So if you access with the double bracket accessor, and I just assigned that to DF and I just looked at the class, but that should actually be, so that shouldn't be DF, sorry. That of course DF is short for data frame, but you get the point. So like when we do the class of that, we get character because we are accessing what is actually in the slot names, which is this character vector right here. So the reason why I can't think of that many reasons to use the single bracket operator, unless you want to do things like if you wanted to select a range of things. I think that's probably the number one. If you wanted to subset the list, I'm not going to show that here, but I'll show you an example in a second. So if I just use my list with the single brackets and cat names, and I assigned it into single list, you can see that it returns a list. And this is why I don't really like the single bracket operator, because if you actually look at single list, it also has a slot named cat names that has our character of interest. So to actually get this stuff out of there, you have to use the double bracket accessor again, because what we have here is a list of length 1, and the slot name is called cat names. So, and again, if this is confusing, I wouldn't worry too much about it. I would say number 1, just focus on the double bracket, using the double bracket operator. Don't worry too much about the single bracket one. And again, I tend to only use the $ or the double bracket operator most of the time when I'm working with lists. Any questions about that? I probably didn't explain it very well.
I think you at least answered my question about it. Thanks.
Yeah, so I mean, if you wanted the one case, just a second, let me get my RStudio back up. The one case I can see it might be useful is if you wanted a subset of the list. So you can say my list, and if we just wanted the first two elements, it's going to return a list of length 2 to my list. I rarely do this. So if this is like totally confusing to you, I wouldn't worry too much about it. So it's just stick to the $ or the single or the double bracket operator. And yes, so the other feedback I got was that the website demo was confusing. So it was just a really quick demo, and I will definitely go over that in more detail when we get to that. So that's probably either going to be part of session part 10, or if people like, depending on how far we get today. There is, so if you're really interested and you just want to start getting stuff online, Allison Hill has this great talk called Sharing Online on Short Notice. It explains kind of a lot of the basics that you need to know to get stuff online. And if you have any questions about it, I'm happy to answer that. But again, we'll get to that kind of at the end. So this is going to be kind of like the cherry on the sundae. So that's that. I fully admit that my demonstration of getting HTML online was totally confusing. So, okay, so I'm going to move over into part 7, Purrr. So I'm going to go into the slides. So this is partly, again, there's not that many slides. So we'll kind of go over the slides right now, and then we'll take a 5-minute break, and then we'll get back into the lab. So let's talk about Purrr. So the main thing with Purrr is thinking that you're working with lists and you're doing things one at a time to each of the elements in a list. So as we discovered, it was either in part 1 or part 2 that for loops were really confusing and hard. I'm not going to go over them again because it's mostly to show you that you can do, like if you have a list of things, that you can process it. But what I'm going to show you is what's called Purrr. And so it makes things a lot easier because you don't have to worry about placeholders. You don't have to worry about instantiating empty lists. It takes care of all of that for you. Okay, sorry, I didn't finish this slide. But the main idea is that Purrr, as a package, it works with lists in general. So we need methods to get things in and out of lists. And I'll talk about kind of some of the strategies we can get things into lists. So our main use case is really going to be, we have a list of data frames, much like you did last time for the homework. And the main thing to know about Purrr, and we'll be going over this in more detail when we get to the lab, is that the main function in it is called Purrr map. And so if you put a list into Purrr map, it always returns it will return a new list of the same length. So we are in effect, like, you can imagine that we have a function that basically generates a plot for each of our data frames that we put in our list. And what we will get when we use map with that function and on our list, and we'll talk more about the syntax when we get to the lab, is that, so if we had 3 data frames and we applied Purrr, anyone have a guess of how many, what the list, how long, what is the length of the list of plots that's going to be output? So we started with 3 data, yes. Yes, exactly. So that's the main thing to know about Purrr, is that it's always going to return a list of the same length. So this is Purrr map. We'll be seeing some specialized cases of map, but it has different names. So I just love Allison's Allison's illustrations. So this is kind of an example of running Purrr. So basically our list in this case are cupcakes. And she has a function called frost vanilla. So they are going to, she's going to frost, and then she's providing this extra argument of vanilla. So basically what's going to happen is for each of these cupcakes is going to get frosted with vanilla. And then it's going to return a list of 3 frosted cupcakes. Okay, so sorry, I was looking for better illustrations. I had to kind of come up with my own for this. But I would just want to talk, so we'll kind of talk about kind of 2 main use cases. So we'll start with a folder of file names. So here we're basically, it's a vector. We're going to treat it like a list. And again, it's very similar to a list, except it's the requirement that everything has to have the same data type. So we're going to have this vector of file names. And then we can apply this function. Again, we can apply the function of map. So we can, our file names that our lists that we're going to apply them to is our file names. And we've written a function called load files. So this is the same function that you played with in your assignment. So once you have that, we can basically make, so this, anything in a box, is considered a list here. So we have a length 2 here. So our load files function is going to basically make a list of length 2, and they're going to contain, each going to contain a data frame. And so this is kind of the second part. So once we have this file list, so again, this is a list of data frames, we can do something we can make a function called plot file, and we can generate a list of plots of length 2. Any questions about that so far? So let's just go over the last few slides. I just want to kind of, again, this is really, just to kind of orient you in terms of what we're going to be doing in the lab. So just kind of take a little time during the break to digest this. So this is the use case 2. We might have a full data frame, and we can use this function called split groups to split it into a list based on a variable. So for example, if we split groups on species here, we will have a list of length 2, and each of these is going to contain one of the a subset of the original data frame. And it's going to be subset. So this is all of these are all of the rows where species is equal to A. And these are all of the rows where species is equal to B. And this is where it becomes really powerful, is that what we can do is we can actually, with each of these sub data frames, we can actually run linear models on each of these subframe. Well, I'm just going to call them subframes for right now. And then we can basically, so we're going to apply this function, and we'll get into this when we get into the lab, called run model. And a run model is going to basically return like a small data frame. And this is, we'll get more into Broom next time, but Broom basically will return a nicely formatted data frame that has all of the information related to our model. So we can have basically, so this is an example of what Broom returns. So like for our intercept and for our independent variable in our model, we can return coefficients and kind of the p-value associated with them. And we can do that for our second data frame as well. And then we'll talk a little bit more about aggregating things. So we may get into map 2. Map 2 is a little more complicated. I was trying to think of good examples, and I ran out of time and I really couldn't think of any. So maybe I'll have some for next time. I just want to point out kind of this last slide. Rebecca Barter, she's, I've learned a lot from her. Like, she has this is a great tutorial called Learn to Purrr. She helped me really kind of understand what's going on with it. So why don't we take a 5-minute break, and let's come back at 4:03. And I'll take kind of the temperature of the room and see how everyone feels. And if there are any questions to kind of clarify, we'll do that before we jump into the lab. Okay, so we are now in part 7. I made a spelling mistake. Purrr has 3 R's, so you can fix that if you like. So let's talk about the learning objectives. So the first thing we're going to do is we're going to load multiple files into a list, and we'll have a list of data frames. We're going to write and use functions that can be applied, or in the Purrr, the Purrr language, mapped to elements of a list. We'll also split and name a list of data frames using group split. I can also there's actually a shortcut way, which is non-tidyverse, that I can also show you if you find group split to be kind of confusing. So we can consolidate elements of a list, like for example, if we had a list of data frames, we could make it into a single data frame at the end using this function called reduce. And then finally, this is really important, is like, sometimes, you may put a data frame into your function and it's going to return an error. And there are ways to do that. It's called failing gracefully. So basically things will kind of continue to process, but processing will stop for that thing that's giving you an error, but the process will kind of continue on. And so there is a function called possibly that we can use for that. So how is everyone feeling about this? Are people feeling uncertain, or are people feeling ready to get into it? And I'm happy to like go over anything in the slides again. Okay. Okay. So, and I will say this is like I have not taught this Purrr before, and this is very kind of programming like. So hopefully I've tried to digest it enough that it will be kind of understandable, and by working through the examples and the homework, hopefully this will kind of cement more of the things, and I will have more I will have some more problems and examples to work through next week. Okay. So like I said, we're going to work on kind of two different ways to use Purrr. We're going to basically, first we're going to make a list of file names using this list files function. So we're going to basically look in our data folder, we're going to make a list of all of our Excel files here. And then we're going to load them up into a list using map and our load files function. We're going to write a function that works on one of the elements in our list. So this is kind of the golden rule of Purrr, is like if you can write it once, if you can write a function that works on one of the elements in the data frame, you can basically, it will work on the other elements of the data frame, or of the list, I'm sorry. So like if you had a function that worked on one data frame in your list, in a slot in your list, it will work on another data frame with this like in another slot in your list. So once we've written that function, we'll basically use map to apply that function to each element in our list of data frames, returning a new list. And then finally, we can aggregate the final results in our final list into a data frame. And again, the second use case, this is kind of where Purrr gets really powerful. So we're going to take a data frame, we'll split it into smaller data frames in a list. We'll write a function that works on one, again, we'll write a function that works on one of the slots, and we'll build a linear model for one of these sub data frames, the subset of our original data frame. So we'll use map to apply that function to each of the smaller data frames in our list, and then we'll get the linear model results out, and then we can aggregate our results using a data frame. So again, I mean, like I said, this is the first time I've taught Purrr, so let's kind of take our time, and like if there are any questions, let's just kind of go slow, and I would just want to make sure everyone's kind of getting it. Okay, so now I'm on line 46 or around there. So we did see this, I think it was in part 5, the idea of not repeating yourself in terms of writing the same code over and over again. And the way to do that is to use functions. So what we're going to do, this is our friend load files. So it is, let's just kind of go through this code. So sorry, I just realized that not everyone knows this word path. So path means the file name and the folder name. If I was being really explicit, I would put a default example here. So maybe data, sorry. So that's an example of a path. So path not only has the, and this is, again, this is a relative path because we are using relative paths in our projects. So what we're going to do is we're going to basically, we're going to use read Excel, and we're going to read the first sheet. Again, we've specified our NA argument as NA. And then we'll clean our data, the names of our data with janitor clean names. And I'm adding, I'm basically adding a column called source here. And this will basically contain our path variable. So let's run this. And then it will return the data frame. So you can see now that we used the files on this file path, and we're assigning it into smoke 1, and you can see what results is a data frame. And if you look, we also have a column called source. And the important thing to note here is that the source value is the same for every row in the data frame. Any questions so far?
So what happens if we want to use load files, whatever we close like this RMD file, and we want to use load files again, like to use this function again? What should we do?
So what you can do, and I'll show you an example. And so the easiest thing to do, and I'll just show you in the assignment. So like I was saying last time, is that you can just have a code chunk in your R Markdown document that just contains this function. So you can just cut and paste it into your files. So there's more sophisticated ways to do it, but that's kind of the fast way to do it. Did that answer your question?
Yes, thank you.
Okay, great. Okay, so now we've got our function. So now we have to have our list of file names. So we need to use this function called list.files. This is not a very friendly function, but I've tried to basically kind of break it down for you. So list files takes a folder. So in our case, we're going with the data folder. So let's take a look at the data folder. So you can see there are these additional folders in here called part 1 and part 2. So we only want our Excel files that are in this folder. So we can put in a pattern, we can put into an argument called pattern. And here we're just basically saying we want all of the files that contain XLSX. So that's basically the file suffix for Excel files. So pattern, Sarah, actually can be anything. So I could put pattern equals smoke, and it will pull out the file names, all of the file names that contain smoke. Oh, okay. So Bradley, so you do not, yes. Can we use the start with stuff here?
Like this function that's like start with or ends with. Can we in the pattern argument?
Yeah, so unfortunately it doesn't. This again, this is base R, so you can't use starts with or ends with. I think you can do like more sophisticated searching. I think you can put in wildcards here, but I'm not sure. Yeah, okay, so Bradley's question was asking about, so you don't need to load libraries at the start of the document if you include the double colon operator. Yes, this is the case. In short, I tend to do it. I should have actually put in library read Excel. And then library, what was it? Janitor up here. So yeah, good catch. In general, it's good to basically kind of at least have put all of your libraries in one place so people can see what if they need to install anything, which libraries they need to install. Okay, so now I'm going to run this list files function, and we're going to look at what outputs. Oh, and the other thing is here I used here because we want, again, if we move this document into a different folder, this is still going to kind of act the same. But the one twist with using here is that it returns absolute paths. but this is actually okay because we are in a project and everything is going, like if we run this on a different machine with a and we're still in the project, it's going to give us a different absolute path, but it will still work. So now we have our files to load list. So we've got 3 files listed here. So again, this is not a list. This is a vector. So what it outputs is a character vector. So if you are confused about this single bracket here, remember when we access vectors, we only use single brackets. So what we're going to do is we're going to load, use the load files function on the first element of our vector. So that's going to be our smoke1.xlsx. And so you can see that works. So that's kind of the start of it. But now we get to kind of the fun part. So again, this is just Allison's illustration because I just like it and it's cute. So let's talk about the map function. So the short answer is that Purrr map lets us apply a function to each of the elements of a list. And again, it's always going to return a list with a number of elements as it's the same as the inputted list. And each slot of the returned list will contain the output of the functions applied to each element of the input list. So let's actually look at a map statement. So map statements tend to have, they usually have 2 arguments. And I don't really like this. I don't really like how these notations they use for the arguments here. But unfortunately, this is kind of how it works. So the first one is the argument is .x. So the .x is always going to be the list that you want to apply the function to. And .f is the actual function you want to apply to. You want to apply to that list. So the way to read this is that we are going to apply our function load files to each element of the list that is called files to load. And so let me just run this first line here. So what we're doing is that, again, we're applying it to our vector of names, files to load, and then we're applying load files to it. And one thing to note is that if we do names on file list right now, you'll see that they don't have names. So a lot of the times it is really useful to name your lists. So I am just going to name lists that give the names to the file list of our original, their list of files. So we have 3, so we have a list of length 3. Each of these contains a data frame. We're just going to name each of the slots. So if I type in names file list again, you can see that these are the names of our files, or of the slots in our list. So I want you to just kind of explore file list and just let me know what's in there. I think I already told you, but just so you can kind of get familiar with it. And how would we get the second element out of file list? So just put that code in, or put that code into chat. Yes. Exactly. So if we type in file list 2 here, so I'm going to comment this one. Oh, I'll just run this one. So you can see we have the second, our second data frame in our list. Are there any questions about this? Because it kind of builds on this. So I want to make sure that everyone's kind of getting this. So we discovered that the map statement outputted a list, and our list is a list of data frames. So what I want you to do is I want you to use map to return the length of each of the elements in my list. And one thing to note is that you don't want to put the parentheses after the function name. This is one of the confusing things about Purrr. And then just put in your code that you used on line 147 into chat. And again, think about what the function we're going to be applying to our list here. So that's going to be our .f argument. Okay, looks good, Martin. Anyone else? Yep, looks good, Colin. So why not the parentheses? Unfortunately, this is kind of the way the Purrr function the map function works. I don't know why. Okay, so the answer I get so far is our argument for f is length without the parentheses. So if we run this, you can see again, we started with a list of length 3, and we return a list of length 3, and it has the numeric values of the length. Yeah, so let's try it. Let's see what happens. Yeah, so it's because of like when you put in the parentheses, it requires an argument. So that is just basic. I guess that's the R way of doing it. And but we'll talk about adding additional arguments to this. So does everyone see that example so far, how that works? Anyone have any questions? Okay, I'm going to move on then. So say we have a list of vectors, and each of these vectors are numeric, and they contain NAs. So if we try to basically, and this is called mylist2, if we try to map the mean function to this, we're going to get a list of NAs. That's no good. So I can't remember exactly what function we've looked at that's like this, but we can add any arguments that we need by adding them after our function. So we can put the na.rm again. That's going to remove our NAs, and then we can run our function. And there's another way to have additional arguments, and I will go over that later. But I don't, and we'll be talking about anonymous functions, but I want to get through the first two use cases before we even get there. So how is this weird, Bradley?
Oh, it's just putting arguments outside of the function that you're using.
Yeah, it's odd. So I will show you the other way to do it when we kind of get through the use cases. Okay. So what I want to do, and I'm sorry I didn't have time to put this in into the slide deck. I literally just finished this right before class. So I want to talk about the idea of reducing. So map always returns a list of the same length as what you're putting into it. So when we want to consolidate things, we actually want to use a function called reduce. And I just want to show you kind of how reduce works. So what we've got a list of length 3 here. And if we use reduce and we use bind rows, what it's going to do is it's going to kind of go down the list. So it's going to take the first two elements and it's going to bind them. And then it's going to produce a list of length 2. And then it's going to kind of keep on going down, and it's going to apply. So this is our new data frame that has both of those original ones. And it's going to apply bind rows to these next two elements. So at the end, we'll finally get a data frame, and it's only going to be in a list of length 1, so a single data frame. So I was kind of debating exactly when to teach this part, but I think it is important. So again, we can use this reduce function on file list, and then we're going to use bind rows here. So yes, Sarah, exactly. So the columns do have to match. And we saw that when we applied bind rows before, remember? I mean, it will try its best if there are mismatching columns, but you're going to get a data frame that looks really messy. So there'll be columns. If there are different columns in like two of the slots, for example, you'll have NA values for the data frame that didn't have that column name. Does that make sense? I didn't explain that very well. Yeah, so they do have to match. Okay, so this is the idea of reducing. So we take our, again, we have our list of data frames and we can apply bind rows to them. And you can see that we basically, I think, actually, I can even show you. So per map file and row. So let's look at the number of rows in each of the data frames. So you can see there's 549, 603, 603 here. So when we apply that and we apply reduce, to our file list, you can see that we have a number of rows of 175, 1755. So I'm going to show you a different way to do this, but I think it is important to think about to kind of separate these two steps. So there is a function that will basically kind of do this, take these two steps that we just did and basically combine them together. But I think it is important to kind of talk about what's going on behind the scenes. Any questions about reduce? And again, I'm happy to go over that diagram again, and I will make sure that's included in the slide deck so you can kind of refer to it again. So I will say, like, you've learned map and you've learned reduce. So congratulations. Like these are the basics of what is called functional programming. And that is using this, like, as long as you kind of, again, like you write a function that works kind of on the first slot of data, like you can apply that function to all of the slots in your list. So, and again, this is just kind of going back to that diagram. You start with a list of length 3, it gets reduced to a list of length 2, and then finally a list of length 1. How are people feeling? Does everyone's brain hurt now? And I'm not laughing because I'm cruel. I'm laughing because I have been here before. Okay, so I'm getting a thumbs up from Sarah, so I'm going to take that as an indication that we can go on. Oh, sorry. So yeah, I mean, it is confusing. So what I want you to do, is use Purrr reduce to find the total number of rows in all 3 files using the sum function, and put your code into chat once you do that. So you want to basically apply to, so we used n row, and like, so now we have a list of length 3 and it contains a number of rows. So, and again, like, you know, so try this out. Oh, I apologize. So file list, so that should be file list. That's a typo. Thanks for pointing that out. I think at one point I had file list 2 in the notebook, and I removed it at some point. Yeah. Okay. So So we can basically use reduce on file rows. We can use, and we can apply the function sum. And you see we get the answer of 1755. Okay, so now we've kind of talked about kind of the basic moves. We've talked about map and we've talked about reduce. So I'm going to basically do something for our first use case. And remember, our first use case is a list of data frames that have been loaded from separate files. So one thing you might want to do is you may want to do a summary of each of the tables that we've loaded into file list. So I can write a function that has the argument df, and again, df is short for data frame. And it's going to take that data frame. Oh, I should actually do a return, but the output of this is basically going to be a table. So that's kind of like when I get lazy, that's kind of what happens. But I'm going to call this, so I'll call this out df return out df. You may have seen so like what happened here is that like with the just kind of the bare statement, that's going to output, like it's basically going, the function is going to return the last thing we output, if that makes sense. In that case, it's our table. So if we apply this to a file list, you can see now, and so we were basically doing a crosstab of tumor stage versus vital status. And so you can see that we've generated it for the first element, our first data in our list. And I didn't really talk about, through that whole thing very well. So I'm happy to answer any questions about it. So make sure that, so I changed it. So make sure it's, so out df is assigned as the output of this dplyr chain here. So I'm just going to paste the new function into chat so you can. I was answering Sarah's question, why it wasn't, I didn't use a return there. Okay, so hopefully that fixed everyone's code. So let's use our good friend map to apply make table to file list. And you can see that it returns a list of length 3. And we have applied our function to each of the data frames. Any questions about this so far? So this is just, again, to show that you can manipulate lists. So I want you to show the table and out lists with the slot name of this. So I'm pretty sure this should work. So just paste your code into chat. Yep, looks good, Martin. Looks good, Jessica. Yeah. Bradley, I think that should work as well. But yeah, since we know that the slot name is named this, we can just basically cut and paste that into here. And we get the third slot. Yeah, looks good, everyone. So any questions about use case 1? So hopefully you can see kind of the power of Purrr. I guess that's what I should have called this lesson. But again, you know, it's really made for working with homogeneous lists where the data type is the same for each slot element. So you can see it like even with just writing a relatively simple function, we can do these kind of complex summaries across like a folder of files. So 3 files might not seem so bad, but oftentimes I do work and I have to process like, you know, 500 files. And so like working with Purrr is like extremely powerful. It gives me kind of the tools I need to like basically understand like a bunch of a whole folder of files. Okay, so we're going to kind of I hope people are feeling comfortable because we're now going to kind of take off like a rocket. Well, not that bad, but I'm going to show you kind of a different way of using Purrr as well. So we're going to be taking penguins and we'll split it into a list with 3 slots. Again, this is use case 2. So we've got a full data frame already. We're going to separate it out with a function called split groups into a list of the sub data frames. And then we will apply a function that runs a model on them. And then we'll also be basically generating a ggplot for each of the slots as well. So I spent a long time kind of trying to find a good way, like, you know, what is the tidyverse way to do this? And I think this is kind of the best way to do this. So what you can do is that you can use this group split function, and it can, it basically, like if you use a group by on it, and then you pipe that into group split. So here we're going to basically take penguins grouped. We're going to make this new list. So this is we're just running a group by on penguins here. And so this is still a data frame here. But group split, if we run group split on our grouped data frame, it will split them out into a list of length 3 with the three groups are the three different species. And we add this argument called keep true because we want to keep that species column. If we don't do that, it basically it doesn't keep the species column. So the default is it actually drops the species column, which I think is a little confusing. So we'll do that, and then we'll look at penguins by species. So again, you can see we've got our species here. And we've got our three sub data frames corresponding to our three different species. So this is where I spent a lot of time trying to figure out what the tidyverse way of doing this, and evidently it's a little backwards. So there is a function called split that you can also use that is actually simpler, but it has a weird notation. And that's why I'm showing you kind of the tidyverse way to do this. So you can see that we have this group split function. There is an analogous function called group keys. And that gives you the name, what should be the names of each of the groups. So, and if I just run group keys on this, you'll see it returns a data frame with a single column and 3 rows. So the fastest way to kind of just make that into a vector is to use what's called this unlist function. So it basically tries to collapse a list down. And so if we look at species names now it's a named vector. So that was kind of a long ways to get these names, but here we're going to use the names function on our penguins by species list to basically, and we're going to assign species names. And so now we have a named list. And I apologize that this is kind of confusing. So you can see it's our penguins by species is a list. And it's got our three slots, and they're named Adelie, Chinstrap, and Gentoo. So now we have our data frames. We started with our original data frame. We used split groups to split it up into our 3 data frames. We just wanted to name our list. So that's what this kind of nonsense is with the grouped keys. And you have to use grouped keys on the grouped data frame, not the list. And my question is really, why didn't they do that? Why didn't they just make the default of group split give you a named list? And I've looked in all of the documentation, they seem adamantly against that. I don't know why, but that's just kind of the workaround that you need to do to name your list. Okay, so the first thing we're going to be doing is we're going to basically make a function called build scatter plot. And so we're going to, and again, this is where we're using that $ notation. So I just need to get the species name. And if we look, so remember, if we use the $ notation on a data frame, we get the vector. So we're just getting the species vector. and we're getting the first value of the species vector. So for the Adelaide slot, what is that value going to be? What is the value of species? Yeah, exactly. So I just want to get that so I can use it as a title. So what I'm going to be doing, again, our function uses a data frame as our input. So we're going to use a ggplot on our data frame, and then map bill length to our X aesthetic, and then bill length or bill depth millimeter to our X aesthetic, and Y is bill length millimeter to our Y aesthetic. We're going to do a scatter plot. And then as we learned about geom smooth, we're going to put a trend line through there. And so this is where I'm just going to add a title. So I can just say title is species. So if I run that on the Gen 2 sub data frame, we will get we'll get our scatter plot, and this is like the plot of our sub data frame of just the Gen 2 penguins. So you might say, Ted, this is kind of pointless. Why didn't you just do this with like, facet? So you can't basically do this. What I'm going to show you next is what you can't do with a facet. So we'll apply our map to our to our penguins by species. So we're going to use build scatter plot. And so you can see it returns a list, and we've got plots for each of our sub data frames. So Adelaide, Chinstrap, and Gen 2. Okay, so I think let's take a 5-minute break. I think that was kind of a lot to digest in a single session. So let's come back at 4:58, and I will be right back. If there's any questions, please ask them in chat. To kind of show Purrr like in a real world application. So I will try to put together like an R markdown file that kind of, and I'll do something like I'll do one of the Tidy Tuesday data sets, and I'll show you kind of how I would use Purrr in that as an example. There is this other kind of way to do this, which, I've kind of taught myself all of the different ways. There's another one called rowwise, which I'm still kind of debating why it exists compared to Purrr, but I think knowing the basics of Purrr can get you really far. So again, yeah, I will have like a Tidy Tuesday like example, and I'll kind of show you how I use it. Okay, so let's get into this function run model. So I want to just kind of take you carefully through this code. So again, we want the species name. So we're just getting that from like the first element of our species vector. So what we're going to do is we're going to use our LM function, and LM is short for linear model. I think have most people kind of encountered this? I know like if you're in linear models, you have to know the LM function. Yes, no? Okay. We're getting 4 yeses. I've encountered them enough to have nightmares about them. Yeah, Bradley, I have nightmares about them as well. Okay, so I'm glad. I just want to take people through the basics of using the LM function then. So the like most models in R are specified with what's called a tilde notation. And we'll get into this in more detail next time when we get into like running more statistical models. But I just wanted to show you this example here. So the way to read this is that your independent, so the tilde in this case, this is what's called formula notation. And instead of an equal sign, because that would confuse R, we use a tilde to kind of take the place of a equal sign. So the way to read this is that our independent variables are on the right and our dependent variable is on the left. Does that make sense so far? And like if you wanted to add more dependent variables on this side, you can actually add another one. So I don't remember any of them. But you could add another variable here to your linear model that way. The other thing to notice is that there's a data argument. And so you have to supply, like if you just ran it without this argument, R would give you an error and is like, I have no idea what you're referring to. So you need to supply it with your data frame in the data argument. So we'll talk more about Broom next time. But what this is going to do, so the output of the LM function is what's called a model. Getting stuff out of the model fit is actually kind of a pain, as some of you might know. So there is a function in Broom called tidy. And it basically returns like important information out of the model as a data frame. So what I'm going to do is I'm going to just add the species column or the species value to our Broom. And this will make more sense once I actually run this code. And then I just want to use relocate. So relocate is a function that just basically, if you give it a column name, it will put that column at the front of, or the first variable of your data frame. So I'm going to run this on penguins by species. So I'm going to run it on the Gen2 penguin subset. And you can see it returned a data frame. And for each of the terms of the model, there's a row. And there's the estimate, and then you can see the p-value as well. And the nice thing about Broom, people have written these for almost nearly every single modeling package. So the output is standardized. And I can't tell you that, like, you know, how much time this saves, because everything is going to come in this kind of format for Broom. So we can see that, like, you know, for our Gen2 species, we have both our intercept term and our independent variable, which was build depth millimeter. And we've got like the estimates, standard errors, statistics, and p-values. Any questions about that? So in my opinion, like, you know, they should really, this is the first thing they should teach you in linear models, because it is way easier than accessing stuff. Anybody have any horror stories to share about using LM?
Yeah, it's called the midterm.
Yeah.
We did probably, I don't know how many LM functions we've done in there, but it would just look gross. Like I wouldn't even want you to look at it.
So yeah, it is really messy. And it's this kind of revolutionized, I mean, it's a very simple idea, but for someone to implement it, they basically had to write underneath this all is there's a specialized function for each modeling package, and the tidy function is smart enough to know which of these specialized functions to use on the modeling fit. So this is I like I'll maybe I should send Tuan an email and just say, like, Tuan, you really need to show people Broom Tidy because it does make your life a lot easier. Okay, so what I want you to do is I want you to use map to apply run model on penguins and species. And just tell me what model list contains. And put your code into chat for running the map statement. Looks good, Stephanie. Looks good, Amy. So you can see we've basically run the model and we've returned the estimates and p-values for each of our subsets of penguins. And we handily named all of the species, so I know which terms belong to which. So looks good, everyone. So this, again, is a list of length 3, and it has 3 data frames which have this format. So what I want you to do is I want you to, this is a variant on map called map.df, and I want you to tell me what happened with it. Yeah, exactly, Stephanie. It basically, it kind of does, what it does is it does a reduce with bind rows on our, yeah, so underneath it all, what it's doing is it's reducing, but it's basically reducing without us telling it to. And we'll talk about this in a second. Yeah. So if you have ever wondered how people run so many models on, like a huge data set, and then they are able to kind of troll through it and get the relevant information, this is how they're doing it. So that brings us into our next section, which is the map, the variants of the map functions. So I will say map.df is probably the most useful, but there are these other ones that exist. So there is map int. So that like whatever your function returns, it has to return any of the functions that you're mapping should return an integer vector. And map int will basically return a single vector that is unlisted. Okay, so is there a way to automate model building so you don't have to individually check whether each variable should be added or not? I will say that's kind of, you know, we talk about things like stepwise regression, but the short answer is that there's not usually a good solution for that. We'll talk about this issue in machine learning when we get to that section when we talk about tidy models. But yeah, it's so there are these ideas of like stepwise regression. You kind of start with a simple model and you kind of keep on adding it until like you get a really good fit or fit to your data. In practice, they're not very good. So building a comprehensive list of models. So theoretically, you could do it. It's going to be a little, I don't know how you would do it offhand. It's going, and that's like a ton of calculations. Even for like a data set that has 4 covariates, you'd see you have to have every single variable combination, and then every single double variable combination, and every single triple variable combination. So again, this is kind of a combinatorics problem, and I don't know the answer offhand, but like you can see as you start growing in terms of number of variables, like it grows in terms of the factorial. So for 4 variables, it's 4 factorial number of models. So yeah, so and we'll talk more about this with machine learning because people think that there's usually a magic answer to this. And the short answer is that if you have domain knowledge and you can kind of apply that to the problem, usually you'll do a lot better than just kind of a blind process that kind of adds and removes variables. Okay, so let's get back to these map functions. So again, so the mapdf function is going to return a single data frame. So your function has to return a data frame. Similarly, you can have, there's map double. So if you're returning decimal vectors, your function should return a decimal format or a double vector. And the main difference between this and map is that these are very strict. So if your function does not return this kind of data type, then it's going to give you an error. So like, here's an example. So if we do, we're going to use map int on my list. And remember, my list is our list of pet names. And we look at, we assign that into lengths too. So is this a list or is this a vector? Lengths too, I mean. So Sarah's saying list. So what I'm going to do is I'm going to do class on lengths too. You can see it's an integer. It's actually an integer vector. So I hardly use like map int. I would say map df is probably the one that you want to focus on. And I think Sarah was pointing out, it's basic what it's doing underneath the map, underneath the hood is it's basically doing a reduce. So it's going to try to unify all of your all of the data frames that you're producing and produce a single data frame. So if we run this, you'll see that we loaded our files. So they loaded into the list. And then the magic of mapdf is it basically tried to combine everything into a single data frame. And so you see we have our single data frame of 1700 rows. So in practice, you probably don't need to use reduce, but I did want to show you what's going on under the hood. Because this looks kind of magical when you first encounter it. And I want people to know what's actually going on. Any questions about mapdf? And like I said, I wouldn't worry too much about the other map variants. Like this is the one that is the most useful in terms of what we're doing. Okay. So we've been basically, now I'm on a section called Failing Gracefully. So you might have a list of files, and what if a bad file name came in there, got stuck in there, and say your list of files was bad, and there was a bad file name in there. So that can basically break map. So if I'm just going to add the name blah to the front of files to load and assign it to the files to load 3. So you can see now we've added this value of blah. If that file name doesn't exist, if you try to use load files on that vector, it's going to say path does not exist, blah, and it's not going to run everything else. But there is this notion in computer science of failing gracefully. So if that function, and what I mean by failing gracefully is if that path name is bad, instead of returning an error, we can force map to kind of return a different value to let us know that an error happened, but it will continue to process everything else in the list. So how do we fail gracefully? There is a function called possibly. So we need to wrap it around the function that we're going to use. So we need to wrap it around our load files function. And when I first encountered that you could basically put a function inside a function, it really hurt my head. But let's just kind of talk about it. So let's look at this on line 412. So we're taking our function load files and we're wrapping it in our possibly function. And we've got this argument called otherwise. So otherwise is a value you want to return if there was if there was an error in kind of processing that line. So we're going to run it on the first value in files to load 3, which is the bad value. It's our blah value. And you can see that when we run that, now it returns a null. So returning a null is actually really useful to us, and I'll get to that in a second. And sorry, this should be load files possibly. Sorry, there are kind of 2 ways to do this. There's one called safely and there's one called possibly. So if we use our load files possibly on our new list, files to load 3 that has a bad value, you can see for the first value, it actually returns a null. Okay, remember load files is that function that we generated at the made at the very beginning that loads the files from the list of file names. So I'll just type. So this is the code for load files. So again, what we're doing is we're basically wrapping it in another function so it can basically fail gracefully. So if we run, we're going to apply this new function. We're not going to apply load files. We're going to apply load files possibly. And it's going to do what's called failing gracefully. So we had a list, we had a vector of length 4. So our list should also have be a list of, so if I type in length, it also has a list of length 4, but the first value of our list is a null value. This is actually really, really helpful, like returning a null value, because if you do like a bind rows on null, and a data frame, it's just going to return the original data frame that you're putting into it. So I'll get to that in a second. So any questions about this before we kind of move on?
Can we use if-else function instead of possibly in this kind of scenario?
You could. The reason why possibly, this is really made for Purrr, and this is kind of the Purrr way to do it. You can do it, but like this handles a lot of like the difficult like error, what's called error handling in the background. So the problem is, you know, like when something returns an error, the execution stops. So possibly, basically, it like if your function that uses possibly returns an error, the map operation won't stop. It will still kind of continue to go. I mean, you can use if else to do this, but it's possibly is like custom made for this, if that makes sense. Did that answer your question? Okay. So why is this important? So if we do a reduce on file list and it contains a null value, it's not going to affect our reduce operation. So we can take our file list that has a null value and it's still going to return a data frame. And again, our first value was bad, so it didn't return anything. So when you do a reduce on a null and a data frame, it will just return the data frame. This is probably the way to use it. If you want to return a single data frame, you can use the mapdf function. And then it will return a single data frame. The one benefit to doing it in 2 steps like this is that you can find out which file is giving you the issues. Does that make sense? So oftentimes, you know, I will be processing like 300 files at once, and like I'll use like possibly, and it will return like a list, and I can just check which of the values in the list are null to find out which of the files are giving me errors. And I can double check and see what's going on. Oftentimes, you know, someone moved something around in the file. So like it wasn't kind of meeting kind of the expectations of the function we're using. And I will say that this is pretty advanced stuff. So are there any questions about possibly? So would you try it without possibly? Yeah, so that's a good question. So oftentimes, Bradley, yeah, so it's an extra step. So if your function works without it on your files, then and it's just kind of a one and done thing, then that's fine. This is more in the case of when you are writing code that's going to be reusable. So like, you applied this you use this map function on one folder of files, and then someone gives you a brand new folder of files and you want to reuse the same code. So that's kind of increases like the ability to use it across different data sets, if that makes sense. Okay, how is everyone feeling? Are you feeling tired, or do you want me to just kind of talk about the last section? Okay. Okay, so yeah, it is a lot of information. So again, well, this is going to be recorded so you can kind of review it. I will say if you're tired and you just kind of want to kind of go right now, because children continue to yell. This would probably be a good point to just kind of sign off if you're feeling tired. And you can just kind of catch up with this section. So I know I do kind of break early, like this is supposed to be a 3-hour class, but I mean, I think just in terms of sanity, I don't think it's really fair for you to have to sit through linear models and well, I shouldn't say that because this is being recorded, but sitting through two long classes. And I think you all are getting this. So if you want to sign off, this is a good time, and I'll just kind of wrap up. Okay, so I was debating whether to show this or not, but when you look at other people's Purrr code, they use this kind of notation a lot. And so there is and when I first encountered this, I was like, I have no idea what this is doing. So this is a shorthand way of defining functions.